Hello, welcome to the AWS Meetup group, formerly known as AWS Denver. Hope everyone's having a good day. I'm going to go ahead and give it about 15-20 seconds and let all the systems connect for the stream, etc. Okay, looks like we are good to go. Like I said, welcome everyone to the AWS Meetup group. Today we're going to cover an intro into AWS IoT Services. Before we get going into the content, I will do a quick introduction. I am Kevin Tin, Cloud Application Architect and a practice lead in the Cloud Application Architecture group at Worldwide Technology. I've been doing that for about 2 years now. I've been with Worldwide for about 6 years prior to cloud consulting as a team lead over in the Agile software delivery portion of the company known as Application Services. Really good experience, a lot of great developers. Prior to that, I was with Eastman Chemical Company. I've been in the industry for about 15 years. Strong software development background. I've done quite a bit of work in data streaming and data pipeline as well. Done that within both Kafka and within AWS and Kinesis, as well as other platforms using technologies such as event hubs with Azure. And so recently, my last 2 years, as I mentioned, foray into consulting services within AWS, Azure, GCP, and on-prem solutions, truly a multi-cloud type of scenario. Prior to the quarantine, incessant traveler, newfound skiing addiction when I moved out to Denver, came here by way of St. Louis and grew up in Tennessee. So with that out of the way, big thanks to Matt Gowie on the last meetup. He did a ECS 101. I'd argue it might be a 201 or a 301, but if you all are interested in the Elastic Container Service offering within AWS, do go out to our meetup, check out the events. Go ahead and give it a quick show here so you know what to look for. Okay, well that is slow. Let's come back to it. So today we're going to cover an overview of IoT services. This is going to include IoT Core, Greengrass, and IoT Analytics. After that, I'm going to get into a Raspberry Pi setup to run an IoT Core client and produce some messages into AWS from a device. So we are going to do that from a device with a real sensor, and I'll show you how I hook that up. After that, we'll get into actually going through the demos and the demo and the commands, as well as hooking up the sensor. Then we'll go ahead and take a look at, if you've been following the meetup, we built out a data pipeline over the past few months that includes Kinesis into Kinesis Stream Analytics, a lot of S3 in there for raw data storage and enrichment, and then also that shoots into Elasticsearch, Redshift, or S3. And Athena's there as well, since we're playing with S3 and converted into Parquet data. So we'll talk about how to hook up IoT Core and kind of the existing data pipeline that we built out. Good news is, since that's all coded infrastructure with Pulumi, I went ahead and deployed it so we can kind of see the whole end-to-end, if you will. So let's jump back here. For some reason, Matt Gowie's meetup is not coming up. I think I've got it here. So yeah, if you all are interested in ECS, do go check out our previous event. Matt Gowie did a great job, and I would highly recommend the content if that's something that you are getting into, or maybe have some technical questions with some projects that you're going through. So jumping back into the agenda, after we connect into our existing cloud-based data pipeline, we're going to get into Greengrass and talk about the Greengrass use case that we're going to really kind of fill out more so in part 2 of this talk. But we're going to get into going ahead and setting up a Raspberry Pi to run Greengrass and kind of act as a broker for your Greengrass, or for your IoT use cases. So just as a reference, source code out there in the repo, there is a Pi folder that has the script that we'll be working from. And then also the meetup link is here. Please join if you haven't already. So to get into an overview of IoT services, let's start with IoT Core. And I've taken some definitions that AWS has published, as well as some diagrams. They make it pretty easy to do these presentations if you just know where to look. So with that being the case, IoT Core, managed cloud service, lets connected devices securely interact with the cloud. What really happens there is these devices can connect into IoT Core and publish into a MQTT topic, which then allows you to route those messages to wherever you need to in AWS, which really provides the breadth of services that you need to really do pretty much any job. And so with that being the case, IoT Core supports billions of devices, trillions of messages, and like I said, can route that to AWS services and endpoints reliably, securely, and lets you really go ahead and fill out your use cases without worrying about too much of the plumbing, if you will. And so the final point here, it will keep track of your devices and communicate with them. And so there's some offline capabilities that are really nice if you start looking at the advanced, features of IoT Core. And so moving on to Greengrass. And so Greengrass is interesting. Once you've got devices out in the wild, past the edge, if you will, then a few devices here and there communicating directly with AWS works pretty well. It scales up really, really well. But there's a use case to kind of have kind of a sensor network, if you will, and then also a server that's on site with the sensors that takes care of kind of higher level processing, sending instructions to the devices. For example, one of the sensors is a temperature sensor that is going to be responsible also for turning off a process if the temperature reading is too hot. You can put that logic into kind of the server component of your IoT ecosystem, and that would be Greengrass. And then it can analyze the messages, and then when a problem has occurred, it can send an interrupt message to one of the devices. And so that way you've got some pretty good governance going on in your non-AWS infrastructure. And another thing that really I think is cool is AWS lets you push out software to the Greengrass device. And so at that point, it starts with pushing out lambdas. So that's pretty easy. At that point, you're just pushing out, Python or Java script-based lambdas out to the device. So you get to manage the code on the Greengrass device the same way that you manage code within AWS Lambda. So some pretty good value adds there. You start talking about IoT, you start talking about over-the-air updates. I think Tesla's really made this something that's more in the public eye. And so with Greengrass, you can certainly do that. So I thought that would be a good call out for Greengrass in particular. And so the final piece of the offerings that I want to cover really quickly before getting into kind of more technical demo and the nuts and bolts of working with IoT Core is IoT analytics. And so with analytics, it offers you the processing and visualization layer that you really need in order to make sense of the massive amount of data that you're pulling out from a sensor network, be it in a car, be it in a manufacturing facility, whatever the use case is. At some point you have to do something with the data. And so it provides the ability to perform ad hoc queries, kind of investigate the data, see what's going on. After that, you can process it, go ahead and get it into a form that's good for reporting, store it in a format that is, I think, it makes more sense with IoT data than just say like a standard data lake. So going into a time series database where you're really talking about time windows and sampling, these are things that are very common with IoT data. And so once you have it in optimized storage, building out your own analysis and queries, and then eventually building out your own analytics and reports to really kind of summarize the data and let people take actions on really what's a very large volume of data. So with that being the case, let's go ahead and start moving on to the setup of the Raspberry Pi. So I'm just going to start from scratch just so we have a good baseline here. So the first thing that has to be done is the memory card that goes into the Raspberry Pi, and I've got a couple of them. This one is running Greengrass, and this one has the temperature sensor in it. And so in these, there is a small memory card, standard SD card. So if you pull that out, and in my Mac, I use a pretty standard dongle. I've got one of the USB-C Macs, so it's got an SD card. So once you go ahead and plug that in, the SD card into the dongle and the dongle into the laptop, that is, you'll end up with this external device. So I don't have these hooked up, but just as a, oops. So disk util list, let me go ahead and clear this and get it up towards the top. So this is the command to go ahead and figure out what are your actual disk IDs, so these identifiers. And so once you find the identifier, going back to the slides for the external SD card, here we've got disk 2, you're then able to go ahead and format that. So let me see, just to go ahead and open the hyperlink. I use the utility on my Mac. I wonder if all of my links are going to be slow today. Maybe so. Maybe so. Maybe it has something to do with the stream. Let's try the other browser. Okay, so I'm assuming my live streaming is making web traffic a little slow. Anywho, links in the slide. The slide is linked from the Meetup, so feel free to get out there. But if you just Google SD memory card formatter, you'll have the ability to download this very simple app. Once you have the disk in here, the external card will show up. I always do the quick format and give it some sort of volume label that indicates it's for a Raspberry Pi. But that's up to you, I think, on the volume label. The quick format I definitely go with because I really just don't want to take the time to completely rewrite the blocks on the card. I feel like that's unnecessary personally. And so once we have the disk ID, and we go ahead and format it, we can go ahead and mount it. And so I found that my ID was disk 2, and so I went ahead and created a directory at the root called mount. And so went ahead and made that directory and then mounted. It's the MS-DOS style file system, and dev-disk2 mounted that into the root/mount. So at that point, we're talking about the OS to put on the card. And so I initially tried the Pi OS, formerly known as Raspbian, but I was having some weird OpenSSH issues. I couldn't verify my certs. And all of this I want to do securely. And with all IoT traffic, do not do it in any kind of unencrypted manner. The data is typically for a use case that's mission critical. And in a lot of instances, there are safety issues involved. So no unencrypted traffic. So OpenSSH not working. It was a problem for me. So then I said, hey, this just seems like the OS is a little, I don't know what's going on here, little scraps. So I went ahead and just put noobs on it, and everything was fine. So also in the links from the deck, you can get out there and get to either of these OSs. They are just a build on top of a fairly standard Linux distribution. So they both work really well for this use case, provided OpenSSH is not junked up on your Pi. And so at that point, to get into the Pi, I don't do a lot of development from the Raspberry Pi. And so at that point, I needed to enable SSH on the box itself. So for this, you have to hook up a monitor and you have to hook up a keyboard and go through all the Pi setup. And once you do, you can issue this Raspberry Pi config command. There's an interfacing options, go down to P2 SSH, and then go ahead and give it a restart. And then once you do give it a restart, you'll issue this hostname -i. And then also I would recommend installing Vim if you're going to do any kind of text editing from the console. Standard VI editor is pretty basic on this distribution, so I would get that. So from the host name, you'll get the IP address. And so with that being the case, I also find it very useful to go ahead and change the host name. So when you SSH into these devices, you know what you're dealing with. So let's go ahead and say that this portion has been completed and SSH has been set up. So now, and from hostname -i, I learned my IP addresses. So having done this, I know that my sensor Pi is 10.0.0.2 on my local network, and I know that my Greengrass Pi is 10.0.0.137. So these are some kind of network details that'll change based on DHCP leases, etc. My router does seem to issue a sticky DHCP lease to the MAC address of the Raspberry Pis, so this hasn't changed on me. So this is a one-time step. So then just to kind of go through the steps to change the host name. I believe this is just Raspberry Pi, and so simply change Pi or Raspberry Pi or whatever this is on the installation to sensor Pi on the Pi that's going to have the sensor connected to it. And then another step here, as the operating system has an alias into similar like the loopback, there is a 27011 that actually points to the external interface of the Pi, which is cool. Interesting Unix networking things. So, and then you'll have to go ahead and reboot. So these things reboot very quickly, but I'm not going to, just for the purposes of time and viewers, etc. And so let's go ahead and just, since I've got my host name changed here, I've done the reboot, you can see that went ahead and took effect. And so when working with these devices from the console, changing the host name is really good, just so you know what you're working with. And then also, if you have any kind of DNS resolution within your local network, if both of them have the same host name, you've got some issues there as well. So that's a practice I would definitely do in my hobbying, if you will, and you have to do in any kind of production setup. So let's take a look here. Looks like the chat's pretty clean. Let's go ahead and move on. So now, and also let's go ahead, actually for the purposes of being complete, out here on 137 on the local network, I've got the Greengrass Pi. So I went ahead and went through these steps to change the host name on both of these boxes. So at this point, we'll go ahead and get back to my local console over here and get into how to start with Greengrass. And so I think it's worth noting that we've got this out in the repo. Let's see, the links have been slow. We'll give them another chance to come up. Looks like that was pretty quick. So if this looks a lot like the data pipeline repo, it is. There are some additions into the infrastructure as code files. Here I went ahead and stood up certificates, etc. I think I've got some time set aside to really get in depth into the infrastructure as code components of this, but I did want to point you to the general direction of the files that are important here within Pulumi. That'd be iot.cs. And then also there's a Pi directory, and I've got a sensor producer Pi file. And so we'll get into getting this out to the sensor Pi and how to get it talking to AWS. And then after that, we'll get into hooking up a real sensor to it. And I think that's really kind of where things get exciting. So if we're just going to go through this, in the console, we'll go ahead and start with the IoT Core security section. Always start with security, word to the wise. And hopefully my internet's going to be snappy enough. Okay, so going out to AWS IoT, make some notes here. I like to be precise with the slides. Get into a secure, and then we'll go into policies, and then we'll go ahead and create a policy. So here we go out here. I've done this a few times, as you can see, but I'll walk through the new setup. So this will be the AWS Meetup group Pi policy. And so here, we want to give this access to IoT Star. For a production deployment, I would recommend being a bit more granular in your permissions, but for the purposes of the demo, we'll go ahead and do that, and we're going to go ahead and allow, and then I have a topic that is called sensor topic, and so that is what I have created elsewhere. We'll go ahead and just create it again for funsies. And so what happens with this policy is we give the devices the ability to operate within those policies. So the devices connecting in with their certificates, they have the ability to interact with IoT services, and that's about it. And that's how we want it. And so at this point, we need to go ahead and start creating an IoT Core instance, a device, their certificate, linking that to the policy, etc. And so at this point, we'll go into the things portion of, manage, and then into things. And so to do this again manually, we go ahead and create an IoT thing. And so there's the ability to bulk onload. That will be an advanced topic that we'll cover in part 2 of this meetup series. For now, let's stick with a single thing. They make that the kind of the default here with the standard where an OK button would be. So either one of those places. So this would be the AWS meetup group IoT Pi thing. You can go ahead and create a Pi. So the one I created manually through the UI is a little bit more readable than the infrastructure as code version. So we'll go with that. Not going to worry about groups at this point or tags or anything like that. In deployment, you should definitely tag all of your things. And then how to communicate. So we can bring our own cert, right? We can go ahead and bring our own private keys and do certificate signing there. What I'm going to do is just let AWS deal with the certificate, which is really, I would highly recommend that unless you have some sort of, typically a compliance use case is where I see this deviating. But certainly for, I think, our demo, creating a certificate, and honestly most use cases, as I was alluding to, this is usually pretty good, usually good enough. Okay, so what happens here is you get 3 different files. And so you get the actual certificate, and this is, I like to refer to this as the device certificate. There is a public key and a private key. And so we'll end up grabbing all of these. And then there's another aspect to the cryptography that needs to be respected, and that is the root certificate. And so you'll want to go ahead and pull that and download it and put it on your device. And so I do know there are some use cases where the cycling of certificates is required for compliance and security reasons. That's a bit more of an advanced use case. Once you get into that, you have to start talking about your own root certificate and authority and stuff of that nature. But for what we're doing, not cycling the certificates, the root certificate here will be fine. I would definitely point out that there is an activate button. If you don't click this, nothing works. I made this mistake, so just kind of live and learn there. Go ahead and activate it. And I don't know that you can get back into this screen once you go ahead and create the cert and attach policy. So go ahead and download all of these. Then also, I'll give you a command line command that you can use for getting the root certificate, because this takes you out to an information page. It's not a direct download link. So let's go ahead and attach the policy with all of our certs and keys in tow. And so at this point, we just created the AWS Meetup Group Pi policy. So go ahead and register the thing. And so we get back in here, and we're starting to see certificates, the shadow, interactions, etc. So we have a registered IoT thing. This is a big step here. If AWS doesn't know about it, it's certainly not going to let it talk to your IoT Core implementation. So with that being the case, this is the command that I would run to go ahead and get that root certificate authority. So let's go ahead and do that. Let's see here. So we are in Data Services Pi. I'm just going to go ahead and do this in IoT Preso. Cool. So pulling that root cert here gives us the Amazon root cert CA1 PIM file. That's very necessary. Also, if we go ahead and take a look at the certificate files that were generated when we created the cert and attached the policy, that's all starting with the CC32. So I'm going to go ahead and move all of those into a local folder, CC32 star. So at this point, we've got all of our certificates, which are very, very important. If you are using the Pulumi code to do this, this is actually available in the stack output, which I find to be pretty neat. So let me see here. I think I can show you a I think that's actually from the Data Services, CDIAC, Pulumi, let's see. Yeah, let's go ahead and just grab this. So here, I'm going to clear this up pretty quick. But yeah, so from Pulumi, there's all sorts of stuff exported from the stack, so you can actually use these commands to go ahead and get them and move the private key and the device. That's what we need. We don't really need the public at this point. We're going to go ahead and rename private to private.pim, and we'll rename device to device.pim.cert. So let's go ahead, and we'll just do that manually over here. So if we take a look at let's see, source, group, presentation folder here. So we'll throw this in here. This is a shorthand for the move command, where you can throw in some curly brackets and basically do a replacement here. So we want this to be named, this is the device, so we'll go ahead and do that, rename there. So we can go ahead and confirm device PIM cert is a real boy. So we'll also do a similar thing with the private PIM here as well. So given our file is hash-private.pim, I want to replace the hash with no characters. Let's go ahead and move the hyphen inside here as well. Well, not working. Let's do it the manual way. So copy paste. So we want to just go ahead and move that. Okay, so I'm not sure what my typo was, but it's definitely real. So we have a private pim.key and private pim.cert. Okay, sorry, follow my instructions. I don't want it to be .key on the end. So we'll go ahead and just move that. So here, we'll go ahead and just remove .key from this. All right, cool. So now we have a device.pim.cert as well as a private.pim. And that lines up with the instructions. So I think we're in a pretty good place. So now that we've dealt with the certs, we kind of got ahead of ourselves with the policy. But as you saw, we went ahead and set that policy to that AWS Meetup group Pi policy, which has allow access to IoT Star. So definitely some good stuff there. So at this point, there's another bit of information that you will need from your thing shadow, and that is an endpoint to interact with IoT Core. So some people hide this. I think it's just an endpoint. It's not really anything of cryptological value, if that's a word. Anywho, so keep track of this. You'll need it later when you get into actually communicating with IoT Core. So kind of get into the next steps here. And at this point, we should have the device PIM cert file, the private PIM file, and then also the Amazon root CA1 PIM file. And so at this point, we need to get these over to our device. And so we're going to go into the sensor Pi, not the Greengrass Pi. Just real quick, I'm going to go ahead and double check and see if these files are out there. Make them go in a vertical manner. So I've already done this before. So we got the Amazon root CA1 PIM, then the private PIM and the device PIM as well. So with that being the case, I've already set this up, make sure it works. So what we'll need to do is go ahead and do a secure copy. And so what we can do here is I'm going to go ahead and just call this upload. So what we will do is go ahead and exit out of here, the secure copy command. Let's see. So if we have an upload directory, so what we're going to do is we're going to do a secure copy of the root cert, or the root CA. We're going to do a copy of the device PIM and also the private, and we're going to go ahead and throw it into upload. It will ask you for the password that you, let's see, /upload. Okay, yeah, that makes perfect sense. Don't put it in the root, please. Okay, so you'll get a little status indicator, pretty quick operation nonetheless. So let's get this back up to the top, SSH back into this bad boy. And also, if you get tired of your storing your password in there, I'm sure there's something you can do with your SSH config. I just don't want to put it out in plain text as an argument since we're on a live stream. So just a side note there. So getting back into here, let's get into the upload. So we went ahead and uploaded our certs there. The certs have to be on the device, so very important step. Okay, so requirements, Python, you can figure out if you've got that by simply typing Python. So let's see, we've got that. Go ahead and quit out of that. Then let's say we want to go into Python and check on the, hold on, window issues. So if we want to go in there and check on open SSL, see if that's there. We can also do that by just importing SSL. And then it's as simple as ssl.openSSL_version. So that's there. So to get out of this little REPL here, it's just a function quit. That's cool. So now we need some code. So at this point, I'm just going to operate out of this upload folder. So let's go ahead and clone the repo. So good to go there. Then there is a Pi folder. Whoops. Let's see. In there, so cd into repo name /pi, and we are caught up with the instructions here. Okay, so at this point we basically set up the Raspberry Pi, and so what we've done is after the operating system was installed, we went ahead and enabled SSH access so that we can interact with it from our standard development box and not have to develop code on a Raspberry Pi. It's not my favorite experience personally. We went ahead and got the certs, And we have an IoT thing with a cert and a policy attached to it that should allow it to go ahead and communicate into AWS. And so at this point, we have to go ahead and install go ahead and configure the MQTT library, and we can run the producer without the sensor attached to it, just to see it communicating with AWS IoT Core. And so just a quick baselining on terms. MQTT, message queuing telemetry transport. It's a very open and heavily utilized standard, a lightweight pub sub sort of protocol, so you can have many-to-many communications. Really pretty interesting. Very lightweight, bidirectional. It's basically designed for small code footprints. I think it was in the 90s, if I'm not mistaken. I looked at the Wikipedia article last night. So it's fairly new, not brand new, but it is basically designed for this use case. And it's very reliable, much better than sending HTTP requests, as HTTP requests can get dropped on the floor. These, once you get the handshake that your message has been received, you know that it's there and it's ready to be processed, and you can move on. Your device can move on with its life. And so, with all that being said, let's go ahead and start installing the AWS IoT Python SDK. And so, getting into that, let's go ahead and run these commands in bulk and hope that they work. Nope. Let's do these. Let's see here. Oh wait, so that's just, I think I didn't run the last command. Okay, well actually let's go ahead and do these one at a time. I had some sort of issue. So I guess we lost it at the CD SDK. So I'm not sure what's going on there. It's strange. Anywho, at this point, yeah, so I just saw a note that the terminal is a little on the small side. Let me go ahead and increase that. Hopefully this is better. Thanks for the call out, by the way. Okay, so at this point, we went ahead and got the SDK. Go ahead and use pretty standard unzip command to grab that. So it looks like I'm not sure where this broke down. So yeah, let's go ahead and just replace the things. Don't know if there's a dash. Yeah, so I mean, it looks like we've already went ahead. Yeah, we've got all the things. I'm not sure why my command blew up on me. I'll have to go troubleshoot that later. So at this point, maybe it's just a single there. I don't know. Anywho. So go ahead and run the install. We will go ahead and get back here. Okay, so I'm gonna have to troubleshoot a little bit on the fly. So what we need is this. If we look at this, we've got the AWS IoT Python SDK. So we need to bring that into the same directory as this, as the code, after we went ahead and set it up. And so we'll go ahead and just copy that / actually, no. So we copied SDK over. Okay, so we are looking for that. Got an extra character here. Let's go ahead and bring it over cursively, of course. Okay, so now we have this compile. We have when we went ahead and did the Python install, we've got the IoT Python SDK. So go ahead and put those on separate lines. Yeah, I think my multi-command piping is not working. Let me fix the instructions. Okay, so at this point, if we should be in a good spot now that we have that Python SDK to go ahead and communicate, to just go ahead and run the producer and see it interact with IoT. So in order to do this, earlier I mentioned this this endpoint that shows up in the interact portion of your thing. Go ahead and grab that. And so we're going to Python. And then let's see what we got here. PySensor producer. And then it takes a single argument, and it is that. Okay, so it's not blowing up. So at this point, we are communicating in a very secure fashion using modern cryptography with the IoT, the IoT services within AWS. So that all sounds great. It looks good from the console. How do you know that's not just a bunch of print lines? A, I wouldn't do you like that. B, let's go look at the messages. So inside of the IoT dashboard here, you've got a test option. So get into test. We looked at earlier, and let's go ahead and just take a look at this code real quick. Let's see the PySensor code. And this is where Vim is going to be much more of a superior experience than standard old school VI. We've got some code highlighting, etc. Let me go ahead and pull this out. We'll get a full line's length here. Okay. This is a pretty long line, so maybe that one's on me. Whatever. So here, let's take a look. Here, remember we pulled in those certs into the root. We'll go ahead and put that cert path there. And we're going against the sensor topic. So with that being said, we're going to go ahead and go to sensor topic here in the MQTT client. And so let's go ahead and quit here. :Q to quit out of Vim if you're not familiar. And then so over here, we can see we've got data flowing in that we can observe in the AWS console. So this is a pretty big moment in our journey. We now have a device that is communicating with the portal, and it's doing so using the certificates, so it's secure. And so at this point, it becomes a sort of a, what is your use case? What do you want to do with this data? And so before we jump into the other side of that, what do we do with this data? Let's go ahead, I think it's pretty neat to, have a device and have it communicating. But really the use case around IoT, to me, a lot of it is just sensor data. So like, let's put a sensor in this thing, let's make it interesting. So I think for us to note is this line here in the JSON message under the sensor reading value, yelly harpoon case or whatnot, yelly snake case maybe. It's just producing a random uniform value. So here you can see temperature here is 93, temperature here is 166. That's just all over the place. And that's because we're just creating a uniform distribution between 50 and 212. Some arbitrary temperatures there. 212 is boiling point. I'm not sure what 50 had any kind of significance here. But that's all well and good. But I mean, if we got a Pi, we want to do like real analog things with it. So that being the case, let me actually take a quick look at the chat. Nothing new has come in. Let's go ahead and jump into the good stuff. And so within a Raspberry Pi, you've got your board. And so on here, you've got the chips and you've got the USB connectors, etc. At this point, you've also got a sensor. So I am working with the sensor that I got is this DHT22, and I just got it from Amazon. And so DHT22/AM2302 digital temperature and humidity sensor. And so these are pretty simple. Pack of 2 is about $12. If you're a Prime member, it's free for the shipping. Weighs next to nothing, so I get that. So with that being the case, here's our sensor. And the way that this sensor works is it has a 4-pin output. And so with that being the case, 1 is the pin for power, 2 is the pin for your data transmission, 3 is a null pin, may be reserved for future use, who knows. And then 4 is ground, so you can complete the 1 and 4 power to ground circuit. Obviously, it won't run otherwise. I think an interesting note on this DHT22 is it's kind of an encapsulation of this sensor, whereas typically if you just had the sensor, you have to connect pins 1 and 2 with I think a 10K resistor. So you get into this Pi board that's very common. And so since just there is no 10K resistor that's only 2 slots here, what this diagram shows is expanding out to enough slots in between 1, now expanded out this far, and 2 in its normal position. These are buses that work from north to south in terms of signal wires. So this is what you would have to do if you didn't have the version, if you just had the version without the resistor on board. So worth noting that this version is nice. You can plug it directly into the board if you just want to start messing around with real sensor data and not have to understand kind of the analog to digital circuitry that's involved with, you know, a lot of the sensors that you'll work with at Pi, the more advanced ones, they don't just plug directly into the board, and you have to do this, you know, wiring together 1 and 2 with a resistor or something to that effect. So with all that being thrown out there, here's a picture of the sensor on the bottom, and you can see here you've got 1, which is power, and then here's 2, which is that signal wire, and then 3 is the ground. And so then if you start looking at this device as it hooks into the board, you've got 1, 2, 3, 4. So they're basically dropping the 3rd null pin. And then on board, this isn't the greatest resolution. They have a resistor here. So I suspect they're running it through the R1 resistor here. And that's how they accommodate all of this and put it onto a single compact board. And so that's probably a little too deep if you're not into analog circuitry things, but I find that stuff neat, so I just wanted to mention it in case anyone else also did. So then there is the connection of the sensor into the Raspberry Pi itself. And so going back over here, and I found these diagrams from Pi My Life Up, very good website. I thought the diagrams are really descriptive, and I think I've got a link in the references section to this. So that could be a very good reference if you get into doing a lot of Raspberry Pi things. Pi My Life Up. So looking at this this pin layout, which if you built any towers, this looks pretty familiar. If you're talking about the motherboard, the pin layout to hook up, connector, or the fan and the case lights and all that sort of stuff. So what we're doing is we need a power, we need a ground, and we need a signal. And so power is coming out of this first pin, the 3x3 power pin, and then the ground is going into pin number 6. So that's actually on the far side, the top side of the board. That's the third one. It counts 1, 2, 3, 4, 5, 6. And then finally the 7th pin, which is the 4th on the low side of the board, that is our actual signal pin. And so you can actually hook the signal pin up to any one of these signal pins, the greens. You can hook the ground up to any one of the blacks, and you can hook up the power to any of one of the 2 power pins that we've got. I have a case that has I don't know if you can see it, hopefully so, there's a little fan in there that's powered. So the way that mine is actually configured, I'm hooking up the sensor signal pin to 7, the ground to 6, this to 1, but then we come out here to the next available power pin. I'm hooking up the power on my fan, the case fan, into this connected. Okay, it looks like my reconnection to OBS Studio is successful. Sorry if there's a gap in the video. These things do happen. And so with all that, let's get back out of the actual circuitry here. Big takeaway is pin 1 from the top view goes on pin 1 of the Pi board. Pin 2 goes into pin 7. This is called, it's denoted sensor pin 4. I'm honestly not sure why that's the case. It becomes important in a second though. And then the ground to 6. So let's go ahead and actually prepare the Pi to use this sensor that I've got hooked up into my board. So we will go back out into the terminal. Let me shrink this. Good looking circuits there. Back into here. Let's go ahead and clear this. That's gotten a little excessive. And also the screen has gotten a little excessive. Okay, so back where we were in that Pi folder, we've got the code here. We get into there, and then we go ahead and I think we've seen these multi-line commands. I outsmarted myself. It's a best practice to do we're using apt here. Sorry about this. So go ahead and do a sudo apt update. In the distribution of Linux on the Pis, it's using apt as the package manager. So this just updates the package manager. The upgrade will actually upgrade any installed packages. This does take quite a bit of time. And then go ahead and, let's see here, get into the install. So I think I may have to look at these instructions. I feel like app's mentioned, then it just uses pip. So I think there might be a follow-up there. So go ahead and install. So I've got already requirement already satisfied. I've already installed it. But the big takeaway here is we want to use the Python installer and install this Adafruit Python DHT. So once we get that, I'm going to go ahead and copy the sensor producer file to a second file location. So I'll have basically 2 copies of it, and it'll have that -DHT 22 at the end, just so that we can differentiate between our kind of random data and our actual sensor-led data. So I've already done this. Let me jump into the file. Okay, actually, I'll just go ahead and follow along with the instructions since I'm in my temp folder. So at this point, pull this up, and so the big changes here. There's not many. This is honestly really easy to go from made up data, random data, into actually using this sensor. The development experience is really nice. So here we're going to go ahead and import this Adafruit library. We're going to get a reference to the sensor. And then remember the data pin that I mentioned being a 4 and not a 7. I wish I had a touch more insight into this for you, but this is data pin 4, physical pin 7. Not sure. Great instructions. Pie my life up. Appreciate that. So back down into the setup. We set the pin, and so inside of, so here on line 1, we go ahead and import that MQTT lib, and so we get that from the AWS provided MQTT client. Appreciate that. Then we get down into, let's see here. So what we will have to do is pull in the sensor itself. So we'll need a reference to it. We can do this pretty much anywhere in the file. And then the data pin itself is a thing. So pull in the data pin. And then the call to actually pull in the humidity and temperature data itself comes from the library.read retry. And it takes the sensor type and also the pin data. And so this actually, let's go ahead and put this here. And then this line to get the data needs to go within the while loop. So we'll go ahead and pull that over here. And so it looks like it pulls back a tuple of readings, both the humidity and the temperature. And so we're going to disregard the humidity, but it is worth noting that it pulls back both of them. And then finally, going ahead and setting here cool. So at this point, we've now went out and got the data. So as you can see, the changes are pretty minimal. Honestly, the most confusing thing is how to go ahead and get the library and get it installed and stuff of that nature. So with all that going down, since we're doing demo, I'm going to just get back into where I've seen this work most recently. Let's go here. So here I've got the DH22 version of this as well. So Python, very similar. Go ahead and run our new file here. And then again, we will need the endpoint, so that's available within the interact portion of the thing. Okay, so now we are producing, if you see here on the sensor reading value, we've got a very constant 25.7.8. That is the actual temperature in my apartment. So we've gone from random data into actual sensor data. So we can go back and use our previous technique to look at sensor topic. And let's go send it some data. And there we go. So this is a pretty big step too. Now we've got an actual device, not in the cloud, talking to the cloud, talking to AWS, and it's using a real, analog to digital sensor hookup. So that's all pretty cool. So now it's, what do you want to do with your use case? So at that point, I think we can go ahead and move on from the actual producer of the messages and start looking at, how do we use this data? And so now that we've got sensor data, let's go ahead and go ahead and just pipe this sensor data into the data pipeline that we've been working on for a few meetups now. And so those are my meetups. Those are not consecutive meetups. We've had quite a few good presenters. And so this probably goes back a few months of actual meetups for the work that we did to create this data pipeline. It is the same repo that we referenced for this presentation. And so just a quick overview of what that pipeline does. We have a sensor producer, and we were kind of mocking this. I was running some code on my laptop to produce some generated sensor data. So we've kind of remedied that where we've got actual data coming from a real sensor on a device that's beyond the edge, if you will. So this comes into an ingestion stream. We immediately pipe all of the raw data out to the sensor raw data. This is a very common tactic in data lake design. Always keep the raw data. You don't know what you're going to need to learn from it later. If you get rid of it, the possibility's gone. And so then we get into the enrichment portion of the data pipeline. And so we have a Kinesis data analytics app for temperature. It goes ahead and it aggregates the raw sensor data with a file that we have that has the, for reference, the current temperature at the location. And so if all of our temperature readings are high and it's 110 degrees outside, there's probably a correlation there. We don't know until we actually dig into the data, but that's the sort of thing, a data scientist may look into is if our temperatures are high, is it due to an environmental type of reason? And so once we go ahead and enrich our data for the temperature readings with the external readings that we have for the site from an S3 bucket, a CSV file in an S3 bucket, we go ahead and pipe this out to another bucket, and then we can and we also transform it into a Parquet format, and we can query it with Athena. And so pretty neat stuff there. We're not going to get into a ton of the data pipeline stuff. You can take a look at the slides or the event. The event has a link to the YouTube video, so if you want to go back and rewatch that, it is available to do so. But really, I just wanted to kind of set the stage for what does it look like to actually use the data from an IoT thing, So this is a common use case I see is A, capture it, B, enrich it, C, give your data scientists a way to kind of query it and peek into it and learn from it. So with all that going down, let's go ahead and get into the mechanisms. So the mechanism used to connect a IoT topic with a Kinesis stream, or really all sorts of sources, destinations, all sorts of connectors. It's really impressive how easily you can pipe this data out to just about anywhere in AWS, is to create a new IoT rule. And so to get to that, inside of the IoT portal, there is an act section. And so go ahead and set up what's called a rule. So very similar, we'll call this the AWS Meetup Group Pi rule. Oh wait, they don't like it when you use the hyphens. Yay, cool. So they've got a few different versions of a SQL syntax that you can use to get stuff from topics. And so here, this is our topic naming convention is pretty basic. So we've got select star from sensor topic. So this is pretty neat. You can actually say if the temperature is greater than 50. So only give us the the messages that are of great concern. So you can do that. You can also use a very common naming convention here is we see it here, IoT/topic, so we can say IoT/topic/ say temperature /star. And so if our topic names are designed like this could come from a variety of sites. So if you think about it, you could have temperature sensors producing two IoT into one topic, or you could have each manufacturing site have its own topic, and you can have one rule that aggregates them all together. Very handy. I think it's worth noting that these are first in, first out, but once you start working with multiple topics, the topic ordering, once it gets aggregated, I'm not sure how well that's guaranteed. If time-ordered messages are critical, I would research that if you're using this multi-topic wildcard pattern here. So that's cool. And so at this point, we'll go ahead, create sensor topic, and then we need an action. And so this is what I think. This is just so powerful here. So I like Kinesis a lot. Turns out you can do all sorts of things. So just a quick sampling here, send it to a Lambda, send it to Dynamo, do multi-column inserts, stuff like that in Dynamo, SNS, SQS, standard stuff there, to another IoT topic, splash it out into an S3 bucket. That's that raw data lake zone sort of storage technique that I see a lot. And there's even the ability to send it over to Salesforce, which is pretty cool. IoT analytics, we covered that just a touch. I want to talk about that more in part 2 of this, but this is really powerful. And so to round it out, you can send it over to an HTTPS endpoint. So pretty powerful stuff here. Since our architecture starts with a stream, we're going to pick a stream. Go in there, configure it. So these are a list of topics that I've got. I've got the IoT sensor reading incoming topic. That would be the choice. You can do partitioning based on date, time, and attribute in the message, etc. I think I've got site ID as a column, and then there's also the role that the rule needs. So this is very important. The role that this rule is going to assume has to do two things. It has to be able to read off of the IoT topic, and it has to be able to write to the Kinesis data stream. So if you're doing this through the UI, and again, I have a coded infrastructure example in the repo under the IAC folder. We can call this AWS Meetup group, something like that. Pi IoT rule policy. Pretty cool. And so it's going to go ahead and infer what you need in order to send it to A, read from the topic, and B, take the action that you configured through the UI. It's smart enough to go ahead and tell you what's going on here. So here we go. Created this. Go ahead and create another rule. I've already got a rule set up, so I don't want to create two since there's some demo components to this, but this should look awfully familiar. So this is cool. Also worth noting, you can have multiple actions off of the same rule. So that's pretty sweet. You know, it really gets pretty nuts when you start thinking about that multi-topic wildcard pattern on the topics, and then multiple sources. All of a sudden, you know, you potentially can send hundreds of topic messages to, you know, dozens of different destinations, and you really haven't written much code at all. And so there you're starting to really see the benefits of the IoT services that AWS kind of brings to bear. So just an aside there. And so at this point we have configured our rule. So that's all fine and well, but like, let's go ahead and see it do stuff, right? Show me the demo. So if we get into Kinesis, we've got the data stream here, and so IoT sensor readings incoming, and I've got a little hash there because I do it from coded infrastructure. That's a Pulumi special. What we really get into looking at this diagram is the kind of the cool step here is when we take our data and then we go ahead and enrich it. That's pretty neat stuff. And so that's actually done in an analytics application, Kinesis analytics application. So let me actually just go ahead and make this a little larger. So we're going to dive into, we're just talking about temperature data today, so we can get into the application details. If it's the first time that you stood it up, I go to SQL results just to look at the real-time analytics for the purpose of a demo. First time you stand it up, this application status will be something like ready, and you'll have to start it manually. So that's just a little nugget there. Additionally, whatever occurs as a result of our analytics is getting dumped out to this temperature enriched topic. So within this analytics application, we're able to transform and enrich, and then also just pipe it right on out. And so very cool and very low code. You know, spend time writing code on hard problems, not the plumbing, right? So here we get a pretty interesting syntax here, where we're going to go ahead and create a stream called temperature analytics topic, and it's going to have the site ID, sensor reading value. So we're basically just selecting so this is specifying the output columns and their type, and then we go ahead and pump from the temperature stream into this analytics, this enriched topic. And this topic refers to a Kinesis, not so much the IoT stuff. We're inside the cloud now, if you will. So we're just selecting our columns off of the message. I think it's important to note that we are not selecting sensor type, because in this analytics application, we're only getting temperature readings, if you will. And so we are going to put this on a temperature topic, so we're no longer preserving sensor type in our list of columns here. Site ID, reading temperature, outside temperature. Outside temperature, that didn't come from our message. Where does that come from? And so temperature 001, I set up a reference table, and I go ahead and join on that. And so that's just one of the columns from the reference table, and we set that up as a part of our analytics application. Again, this is all in the IAC, or you can go back and look at the previous videos to get more information here. But basically, based on a site's identifier, what is the outside temperature? It's a real simple CSV file, but it's an example of reference data nonetheless. So that's kind of how we got here, and then we can get into the real-time analytics. So this is basically listening to the topic to see the data. And so now that we're pumping data in from our Raspberry Pi over here, we can come into this real-time analytics window and kind of do a sanity check. This isn't really something people use in production. This is us as the designers, the architects of the system, coming here and seeing the data, getting a chance to sample it, see if it makes sense. So we're only producing messages with site ID 1, so that makes sense that we're only seeing that. And then it's just going ahead and joining it over to this outside temperature from that reference file that we looked at. So from this. So 98.6 is right on point. So now we've got a pretty interesting scenario where the data is being captured on a sensor, then transmitted from the Raspberry Pi into an IoT topic, and then an IoT rule is routing it onto a Kinesis stream. And the Kinesis stream, as we worked on previously, has this whole analytics and ETL pipeline attached to it. So very easily we've gone from basically nothing to a full analytics pipeline running on a Raspberry Pi. You could argue that there was time dedicated to creating the data pipeline previously, but very little time spent getting all the way from scratch up to this point where we've got a lot of sophisticated stuff going on within the data pipeline. So I feel like I've covered quite a bit. Let me double check with the notes. I think we're getting pretty close to So the next thing I want to do is jump in quickly into the infrastructure as code, then check for questions on the chat. Here is this is Python code. Oh, one sec. Let me go ahead and find the actual code. So cd source AWS Meetup group data things IAC. I'll just open this up in Visual Studio Code since it's C#. Cool. So just to kind of take a look at what we've done specifically to IoT, and we looked at this a little bit before. If you remember, we created a policy so that we could do IoT things. I'm actually using the same policy for the IoT rule and the IoT producer. So I gave it Kinesis star privileges as well. And if you remember when I talked about the creation of the rule inferring what permissions you need, it would add something like Kinesis, producer. I forget the exact name here, but I've kind of combined both of those policies into one here. So here I create the Raspberry thing type, and if you remember from the UI, yes please, any day now. When we created our thing, which is under the management portion of the console, one of the options is to give it a type. So that's simply what that is. That's that type. You can do all of this. You can do most of this stuff through code. I ran into a limitation in my knowledge of Pulumi for Greengrass, but other than that, all the stuff we've shown so far can be done through code. So additionally, we go ahead and set up a certificate. What we're going to do is attach a principal. We're going to do the principal attachment, which is going to go ahead and attach this principal here, the cert for that IoT thing, into the IoT name. So now the IoT thing is associated with the cert. So when you connect with a certain cert, it knows which IoT thing it is that you are connecting from. So that being the case, we also have to attach to that cert the policy. And so this device that's associated with the cert is associated with the policy. So by a kind of a multi-step hop, the device now has a policy that it runs under the context of, if you will. Kind of butchering the terminology there. I hope that's a decent enough description. And then finally, the topic rule, which goes ahead and enable it. We've got sensor topic. This really should be topic based on what we've seen in the UI. And it will go ahead, partition key, that says site ID. The role arn is that topic rule role. And then we've got the stream name. And so with this has the ability to write to Kinesis. Whatever your action is, you're going to have a policy that allows you to interact with the services that your action is going to direct data to from IoT. So I think that's all I really wanted to show from the infrastructure as code. There's a lot more in here, but we covered most of it when we set up the data pipeline. So I think now that we're back out of the code, also I really like this image of Margaret Hamilton, who wrote a ton of software for NASA, one of the original female rocket scientists of the computer variety. A very interesting person, very, very distinguished software engineer. I think she actually received the Presidential Medal of Honor. Can you imagine that? Writing software so good that you get a Medal of Honor? I can't. Maybe one day. We can dream, right? So just a quick jump back into the chat itself. Looks like we have no questions on the chat. At this point, what I've got left for today's meetup is I'm going to go through a quick rundown of the IoT Greengrass use case that we're really going to get into in earnest, as we're already an hour and 17 minutes into this. Next time, but I will go through a quick setup of the Greengrass Pi, just so that we have that out of the way for the next time around. So before we get into Greengrass, we talk about it as kind of the, if you talk about a client-server paradigm with your local on-prem IoT sensor network, Greengrass is kind of your server. And so, well, it is your server to a certain extent. You've got a Lambda that you can actually ship out to the IoT Greengrass device. So that's pretty neat. Basically, the software that gets into the Greengrass runtime is going to be software that you promote from the AWS console, which gives you a lot of power in that whenever you need to go and update some processing logic that is running inside of a plant with a sensor network, for example, you don't have to go and update each Raspberry Pi. If we wanted to update the logic on our Raspberry Pi, our sensor Pi, you saw that we had to go out there and install the library to read from the sensor, write the code to actually do the reading of the sensor. And so that was a legitimate software deployment that has to occur to each single device, and you have to go and touch those devices, and it's not a good situation. It doesn't scale very well. So that's where Greengrass comes in. So you have the most simple of logic on your IoT kind of core devices, if you will. And so that's simply, give me the sensor reading, and I'm going to send it somewhere. And so where we saw our sensor reading data was in Celsius, let's say for whatever reason we want to convert it to Fahrenheit, usually it's the other way, right? Really, that calculation, takes up CPU on the device here that's really just supposed to be reading the sensor. And also, let's say we get some requirement that, down the road we want to convert to Kelvin and not Fahrenheit or whatever, So at that point, do we go and put new software on each single device? Well, no, we just ship out a new version of this processing Lambda to Greengrass. So very powerful. So the software running out here, really doing the processing, can be enterprise approved software. It can be software that's gone through all of your standard quality control and testing. it really eliminates kind of that rogue software situation that comes from a disconnected device sort of paradigm that's very common in IoT. And so really at that point, Greengrass is responsible for interacting with your MQTT topic within AWS. You can set up as many rules as you want to off of a topic. You can also set up one rule with multiple action destinations. So, kind of the use case we're going to drive towards with Greengrass in the next installment of the IoT series on the AWS Meetup group is to really kind of implement this and see it going out to some sort of analytical platform. If I run out of time, it'll be Kinesis because I've already got it. But what I really would like to do is get into IoT analytics with the group and do some kind of hands on the keyboard sort of examples there. So that's what we'll be driving towards in the next installment of this. And so in order to get into Greengrass, we'll go ahead. There's a few slides just on the initial setup. I've included a guide for the setup of Greengrass, but just to get into it from the console. So let's see here. So you get in, create a group, give it a name. Then it's going to go ahead and create a device. For the group, there's going to be a core. And so this is your actual server itself. And so this is where you actually deploy your Lambda functions to. This is the kind of the server in our paradigm, the client server paradigm we've been talking about. Cool. So once you go ahead and create the group, you create the core device as a part of that, you end up with these certificates. And so you'll want to go ahead and pull all of those down. This should seem familiar. New addition here is a JSON config file. And then also you'll want your root certificate authority as well. It gives you some prereqs. You don't actually need Java 8 unless you're doing the stream manager, which is a pretty neat feature. I think I would want to use that, but not necessary. You could have your Lambdas just, spinning up an MQTT client, but with the stream manager, you do have the ability to not have to kind of hand roll your own MQTT producing, and you can basically point and click and send it out to a Kinesis or IoT analytics package. So go ahead and grab these. It'll actually give you the full tar here, give you the full archive. So here we go. So now we've got our new certs. So getting into that setup a little bit further, what you'll want to do is copy the entire credentials bundle over. You'll also want to go ahead and copy over the root certificate, and then we'll go ahead and actually get into the Pi itself. So just to see here. So I think we are done with sensor Pi. Let's see here. At this point, let's go ahead and get rid of the second window. It's probably tough to see. So at this point, SSH into the IP that I know belongs to what I'm using for the Greengrass Pi. We'll get in there. Since we changed the host name, we get confirmation here. We'll do much of the same here, where I'm going to create an upload directory. Since I've already done this before, I do want to go through the steps with the certificates. They're very important. You have to do them exactly right. But I don't want to overrate the stuff that I've done before. So at this point, we'll go ahead and do a secure copy into this upload directory that we created. So this is from the relative home for the user, which is Pi, and we'll go ahead. Actually, let's see here. So I think those are in my download folder. So let's go ahead and also let's take a look at what that hash was. It's different every time. So it looks like this is an E43 hash. Sorry, no, that was tiny. E43. And so what we're going to do is we're going to go ahead and send that archive out to the upload folder on the remote. Again, need credentials. Security is important. And we are also going to have to do the same thing with the certs. And so, with the root, the certificate authority. So back into here. Let's see. So we've actually got that local. Whoops. Keyboard problems? 99 of them. So we'll just go ahead and get this root CA here. And again, we're going to go to the upload directory on the Pi that I just created. Passwords for safety. Let's see. Oh, yeah. Cool. So now if we go back out to Greengrass Pi, do an ls. Actually, let's do an ls-la so we see stuff vertically. So we get into upload. We'll see that we've got the cert here as well as the bundle of keys, etc. So back in here. There are some steps for the actual device that you have to go through. So firstly, we'll go ahead and create a user and a group. And so GG is the shorthand for Greengrass. So we're basically creating a Greengrass Core user and a Greengrass Core group. So, and this is required. This is just, so I've already got these. That's good news. Those group names I think are hard-coded or in some config file or something within the actual Greengrass runtime. And so here, let's go ahead and do things with certs. And so what we're going to do is, we saw that this didn't seem to work super great. So let's go ahead and So I've already created this and done a lot of this configuration, but what you want to do is, if you're starting from scratch, go ahead and make a directory at the root. It's just called Greengrass. This is where the binaries and the runtime is installed. Greengrass does look for it to, the daemon does look for that stuff to be there. So very important that that is there. So go ahead and change over to there. Let's go ahead and get a vertical listing here. The next step is to create the certs and configs directory. So pretty standard stuff, make directory, certs and config. So actually, now that I look at that, that's from the relative root. Let me okay, so this is not accurate, and I'll publish a new set of slides out there. So we're going to put this all within the certs and config directory in Greengrass. May have done this late at night. So we'll go ahead and I see what happened here. Yeah. So that was actually correct. So I think we did have all this stuff in the root if we followed the instructions. Okay, sorry about that. Anywho, there was a, let's see here. So you will have to unzip the tar and get your certs. I didn't include the instructions to do that. So let's say, just for the purposes of completion here, E4. So it'll go ahead and pull out these files here. And so what we are doing in these commands was this was done initially in the root. So we are pulling the certs and config directory into this root / Greengrass directory that we have. So if we go ahead and look at Greengrass and then certs, for example, those all got extracted there, as well as the root cert. And based on the config, we had to name it root.ca.pim. And so that's what this command does, is we've got this at the root already. Go ahead and call it, or copy it into Greengrass, because we're in this directory currently. Certs root.ca.pim. So pretty cool. So we're good on the certs there. So let's go back into Greengrass itself and take a look at this config file. Wow, good one, Kev. So if we go ahead and look at the config, so what it does is it gives you, that's what this specification here is why we have to rename that to root.ca.pim. And it automatically generates this, so it's going to go ahead and have that hash on the front of it, which is great. It's got your IoT host here. It's got the Greengrass host, and it's got path to private and the device key. And so that's why we had to get all of this stuff over into the certs directory. So the instructions are specific because the config is very specific. Oh, wait, no, that wasn't VI. Whoops. All right, anywho. All right, and moving on. So there's some dependencies to install. It uses SQLite. You can run node-based lambdas if you want to. You can do stuff with Java. Going back to that streams manager, if you don't have Java, it gets pretty upset. So some basic configs or some basic configuration around the Greengrass dependencies. Then also, I looked specifically for Java 8 as a command. So at one point I did that. So at that point, there is a Greengrass dependency checker. So let's go ahead and give that a whirl. So if you follow these instructions, you end up with this Greengrass dependency checker ggc v1.10.x. So I went ahead and followed all of this since we're kind of running late on time, and I apologize for that. Let's go ahead and just take a quick look at what that dependency checker looks like. So once all this is installed, let's see here. One more, right? Sweet. And so here I am missing a prop config. So it comes through and talks about some dependencies. So I wonder if I have actually started Greengrass. I think that might be the issue here. So let's go ahead and cool. So given those are system level commands, needs a super user do this thing. So at this point, we can take a look at the Greengrass daemon and started the Greengrass daemon. So that feels like a win. And so with that being the case, after all of the installation steps here, get out of here. Cool. So we get up here and it's finding Python. Let's see here, and just general dependencies that it's got. Not sure what's going on with this. So I think in my new installation, I haven't quite gotten into the mod probe configs. But at this point, we've got the software out there. And that's really pretty much as far as I wanted to go, was to getting this Greengrass service up and running. And so with that being the case, and we're running pretty short on time, that is as far as I wanted to go into Greengrass today. And so we'll get into, in the next installment of this, pushing code out via lambdas to Greengrass, connecting the sensor device to the Greengrass core device, and then using that lambda that was pushed out from the console to process the sensor data and do cool things with it as an intermediary. And then also start talking about some bidirectional communication within the IoT services, just touch on device provisioning, a little bit more on security. There's some really interesting use cases based around edge-based machine learning, where SageMaker models can actually be pushed out, and Jupyter notebooks, etc. All can get containerized, and so you can do some pretty cool machine learning things out on the edge, if you will. Then also get into that stream manager to easily connect into Kinesis or IoT analytics. So with all of that being said, thanks for tuning in. In the slide deck, I've got a bunch of good references if you want to get in and work some of these exercises yourself. And then in terms of upcoming events, we've got a meetup early September. Austin is slated to do that. I think he wanted to talk about some really cool stuff he's been doing with Glue and AWS data in general. And then after that, in October, on our monthly installments, we'll go ahead and talk about IoT again and get into part 2 of this meetup series. So thank you all. Shameless plug, Worldwide Technology. We do a lot of this kind of work. So if you have any projects that you're working on that you need help with, just hit me up on LinkedIn. And I will go ahead and check the questions one more time. And it looks like we do not have any outstanding questions on the chat. So with that being said, thank you all for tuning in. I know this is a little bit longer than what we try to strive for, so thanks for hanging in with us. And tune back in next month for Austin's meetup, and I hope you all have a good night. Thank you so much.